Okay, so we've got our piece enum, but what we want to make is a board, is a whole bunch of them. So in this video, I'm going to have a look at arrays. I guess we can get rid of this test piece. We won't use it. I'll just go over to the game and I'll just up above, I'm going to decorate this with a few properties. So in order to, actually, you know what? I'll leave that for now. I'll get to it as we need it. So what I want to do is I want to make an array of board pieces. So one approach is to go, and the array type, the way this works is we write the type of variable and then the number of entries in the array. So the type of variable will be that board piece enum, and let's say we want 5 entries per row. Now we need to instantiate this. So what we can do is we can say, okay, we could go board piece none would be a sensible starting value, and so on and so on and so on. Do that 5 times. But a shortcut, if we're copying the same value, is just declare the piece that we're using and then the number of elements. Now this will throw an error and it will say, well, where are we? Yeah, it's saying, well, we can't really copy these things because we haven't specified that this is an enum where the values can be copied. So that's where this derive comes in. So we decorate it with a property. So let's just go copy. But it still complains because copy inherits from clone. So we'll go clone and copy, and there we have it. And then if we want to make this a 2-dimensional array, we'll just wrap this up again, and this will be, this first bracket, square bracket stuff, will be the element of the array, and I want 5 of those, like 5 rows going down. And then it's no problem just to take this stuff. But then we'll have a problem, and the problem is, for instance, let's make a function that messes with the elements a little bit. So we'll go public function, I'll say jumble board. I mean, it's a good idea to change individual elements and check that they are independent of each other. So what I want to do is I want to go board row 1, column 0, set it to red. But if we save this, we'll have an issue. And the issue is that Rust is saying this sort of thing is, what am I doing? Public static mutable. So that's one thing. Yeah, but then it's saying this is unsafe, and with good reason, because basically if our program is multi-threaded, there's no guarantee that only one thing is modifying this variable at the same time. If we wrapped it up in a class, then of course it would be safe, because standard non-static data, so static is the issue. Static means it can be accessed from everywhere. Non-static data still has the same borrowing, Rust borrow check and all of that, which makes sure that only one mutable reference is being used at a time. So one thing we can do is mark this as unsafe. But then the rot sets in, because then we have to start using unsafe everywhere. It's a bit of a nightmare. So what I'll do instead of all this, is I won't make this variable, I won't make it public. I won't make it static, I mean. I'll make a struct to wrap it all up. And I'll say, okay, we'll have a board. And the data type of the board is the same. And then, well, when we construct this, how do we pass it? I mean, we could pass this in. This is fine. But just to help, what I'm going to do is I'm going to make a function called make blank board. That will return this one here. And essentially, it will just return this. There we go. Okay, whoops. So when you have a function you want it to return something, you can use the return keyword, or you can simply write as the last line with no semicolon what it is you want to return. Okay, so now we have this stuff set up. What I'll do is I will just start writing some functions for the game state. One of those will be the jumble board function. I'll keep that. Okay, so we don't need the unsafe. So the jumble board will Right, so now this is completely safe because we're not working on a static variable. We're working within the borrowing system of Rust, and this is ensuring that only one thing will be working on this variable at a time. So in addition to that, I'm just going to write another function which basically just prints out the contents of the board, because that could be useful. And we don't need a mutable copy because we're just reading the data, we're not writing it. Okay, so far so good. We look through each row and column and we check the corresponding entry and say, does it match? Now, we are having an issue here with this equal sign. So what we'll need to do is go back up to the top and derive some more properties. So in addition to that, we'll derive partial equality and equality. And now those values can be simply checked. Okay, great. So we just basically convert those into strings, and then once we've selected what will go on the label, we will, and of course, after we've done each full row, we'll print a blank line, and then just so that everything is nicely separated, I'll also print a blank line after we've printed the whole table. So if I repeatedly call this function, there will be spaces between the boards. Anyway, so these are some examples of how we can set values in an array, how we can read values in an array. And yeah, so let's go back and test this. So we'll go back to main, and I don't think we need this bit. We will need make blank board and game state. Okay, so I'll just go down to where I was and I'll say, okay, we'll make a variable. Yeah, and for the board, we'll call that make blank board function. Excellent. So we've populated that. Yeah, it's fine. Then let's go ahead and print it. And just run this right now and check that it's... What is that complaining about? Ah, it's fine. Okay. So, oh, yeah, let's get rid of those print statements. That's messing up with making the terminal hard to read. Okay, excellent. So we can see that, yes, we have a completely blank board. So now let's jumble the board a little bit and then print it again. Okay, so as we can see down on the left, we started completely blank. We set those entries and they have been set independently of each other, so we don't have weird things where we're copying a reference to the same data set. Anyway, it works. The point is, it works. Excellent. So yeah, that was just my quick example of working with arrays. See you in the next one. Bye.